Okay, so this is week 4, semester 2 on a Wednesday, and we are reviewing for ratios for Math 6. Okay, this one says Carly's class built some solar power robots. They raced the robots in the lot behind the school. The graph below shows the distance d in meters that each of the 3 robots travel after 10 seconds or 2 seconds. Each graph has a point label. What does the point tell you about how far the robot has traveled? Okay, so point label is right here. The graph below shows the distance in D and T for travel. So going back to this right here, D, okay, so this is kind of what we want to first look into, right? So remember X is right here. That's time in T in seconds. T, 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 right? And actually T stands for time in seconds, right? Actually, I shouldn't even do that. Remember, each of these points here represents an X and a Y. X comes first because of the alphabetical order. T right here is X, which is time traveled. Y is right here on the Y-axis, distance in meters. So this right here represents distance in meters, right? So the question here asks you, what does the point tell you about how far the robot has traveled? Well, so what you can do is we're gonna have to write something with this. So let me grab this piece right here. And essentially, hey, Emma, stop. Stop talking. So essentially what it says is it's giving you an X comma Y, which is equal to T, which is the first one, is time in seconds, and D, which is distance in meter, right? Is that correct? So when it says, what does a point represent? It represents that the 3 points represent when time is at 1 second, the robot traveled 5 meters. Okay, that's the first one, right? Second one, when the time is at 5 seconds, the robot, Emma, stop, traveled how many? 2 meters, right? That's kind of weird though, because it seems like, is the robot going further or is it going shorter distance? Look at how much it's traveled. Is it going further or shorter distance?
Maybe it's going shorter.
When the time is at 6 seconds, the robot traveled 9 meters. So it's like some robots are traveling further and other robots are not traveling as far, right? So some robots are traveling further within a shorter time, while others are traveling short distances within a longer time. Okay, that's kind of what it means. So we're going to go back over here. And you can go ahead and look at this. However, I mean, it's not a linear function, obviously, because some are traveling further within shorter time, other are traveling shorter with a longer time, right? Okay. B. Carly said that the ratio between the number of seconds each robot travel and the number of meters it travel is constant. Is she correct? Do you think she's correct? Okay, so look at this. When the time is 1 second, the robot traveled 5 meters, so the 1,5, right? Look at 1,5. Second robot traveled 5,2. Well, that's the one that's kind of shorter, right? The third one is traveling 6,9, right? Do they look consistent? Emma, I'm not gonna ask you again. Stop. I need you to stop. Thank you. So it's not consistent. Consistent, or not consistent, constant is what she said, I believe. Constant. Constant means that it's linear, as in like all these point to a straight line. Like for example, if this is the time, this is a distance, constant would be like at 1 second, she traveled 5 meters. At 2 seconds, that goes to 10 meters. At 3 seconds, that goes to 15. At 4 seconds, it go to 20. Do you see how each of these is just added by 5? This is constant. Does that look constant? That does not look constant, right? So you can say something like, no, Harley is not correct. Correct. You could say the robots are not traveling you could say the distance that the robots are traveling in meters are not proportional to the time in seconds. Some robots are traveling further within a shorter time. Others are traveling shorter distances within a longer time frame. Okay, and that's what you can say. Okay. Okay, next one is C. Which robot is traveling fastest? Which one's traveling slowest? Okay, so this is where you're gonna have to use your proportional, or what was the term she used? I keep forgetting. It was called proportional relationship. Okay, this is the one we're gonna have to do the proportional relationship. Okay, your proportional relationship of this is going to be the distance traveled in meters, okay, divided by time in seconds, right? Okay, remember there were 3 points. What was the first point?
The first week was
1, 5,
5, yeah.
and what was the other one? 5, 2, and then what was the last one? 6, 9. So you will have to write them. Distance traveled. So this is actually time, right? And this is actually the distance. So make sure you put 5 over 1, 2 over 1, and 9 over 6, right? If you do distance traveled meters divided by time in seconds, this is going to give you distance traveled per second. So for every second, how many meters is it traveling? Does that make sense? 5 divided by 1 is 5. So that means we are traveling 5 meters per second, okay? 2 divided by 5. Put a dot, 0, 4. So this is traveling 0.4 meters per second. So 1 second, they're only going 0.4 meters, okay? The first one is going 1 second every 5 meters, okay? This one, 9 divided by 6. So 1, give you that. 3, put a dot, 0, 5. So this one's traveling 1.5 meter for every 1 second. Do you see that? Which one's the fastest? Which one's going the furthest? 5 meters per second, right? This one is traveling the fastest. Which one's the slowest? No, that's 1.5. This one is the slowest because it's only going 0.4 meters. Do you see that?
Yeah.
Okay, so let's go ahead and answer the question. You could say something like the 1,5 robot is traveling the fastest. I know this because 5 divided by 1 equals 5, which means it's traveling 5 meters per second. Does that make sense? Okay, so that's the first one. Okay, then your next one, you can say that 0.4 is the shortest, right? So that one's 2,5 robot is traveling the slowest. I know this because when you divide 2 over 5 equals 0.4, which means it is traveling 0.4 meters per second. Do you see that? Okay. And that's it. One answer you're answering that is about fastest, the other one the slowest. So you don't want to mistake this. You do not. No, you don't want to do seconds over meters. Okay? And the reason for that is because you want the distance on top divided by the second, so that way you know how far each robot is traveling for each second. So time has to be in the denominator. Does that make sense? Okay, so you want to be careful with that one. Okay, so that could be a little bit confusing. All right, let's go on to the next one, which is, what is the speed of each robot? Describe how you found this from the graph. When you look at this graph right here, what do you see, Grayson? Does this, I mean, I see grid and I see points. Does this kind of remind you of like a slope, sort of? Yeah. Which one to you look like it has the biggest slope, like the most steep slope? Remember, this is time, this is distance. Time, distance. Okay, because do you see how from here to here, it's a lot more steeper? Like this is more steep, right? Compare from here to here, this is more flat. And C is definitely flat. Do you see that? So what is the speed of each robot? Well, you have 1,5. So remember, this is time and distance. We want to do distance divided by time, which is 5 over 1, which is 5 meters per second. This right here, distance divided by time is going to give you the speed. Okay? That's the first one. Okay? This is your speed right here. Your second one is going to be 9 divided by 6, right? This was 6 comma 9. Remember, this is time, this is distance. Distance divided by time is 9 divided by 6, which is, what was it, 1.5? What was it? 1.5, yeah. Which was 1.5. What just happened here? Which is 1.5. Why is it disappearing? Gosh dang. Okay, 1.5 meters per second. I don't know what the heck is happening here. Well, anyways, it's supposed to be there. Third one that you have. This is so annoying. I don't. Wait a second. Okay, hold on a second. This is not working. Okay, so going back to this, 1.5 meters per second, right? That's your speed of the second robot. The third robot is going to be 5 comma 2. Remember, this is time, this is distance. Distance over time equals speed. So 2 over 5, right? Which I think we determined was 0.4 meters per second, right? So when it says something like, describe how you found this from the graph, something that you can say is speed is equal to distance divided by time, right? Each of this, the x value represents the distance or time, and the y value represents the distance. I divided the y value by x, which equals speed of each robot. Okay? Speed of each robot traveling meters per second. Okay? And that is it. That is your homework. And that concludes everything.